Hey YouTube, welcome back. In the previous video in our series in designing WhatsApp, we did talk about why we prefer to use WebSockets instead of using polling or long polling. So if you're new to this channel or in this video, we did create a series that talks about designing WhatsApp in system design. We start with the high level design, as you can see. We had the functional requirements, non-functional requirements. We started with the high level design, then we went to the database schema design. After that, we talked about what type of protocols that we use, because we did talk about that we're using WebSockets. We did create a video about why using WebSockets was a good idea. And now we will talk about the real-time messaging delivery using WebSockets. So again, in our last video, we learned why WebSockets are ideal for real-time communication. Now let's take it a step further and let's say how do real-time messaging apps actually deliver messages instantly from one user to another. So this video will be a pretty quick video. We'll just discuss this topic only. So when a user opens a chat app, it creates a WebSocket connection to one of the chat servers. Let's have here a server A and server B. Let me get the pin. Let's say that we have here a server A and a server B. This is too thick. Is there a way to make it even lighter? Oh, this is lighter. Okay, so let's just remove them. So we have server A, we have server B. And yeah, the user A and user B will have like a WebSocket connection, and this connection will stays open the entire time the app is active, like no repeated HTTP request at all. So the journey of sending this message goes in two sections. First, the sending message. After that, the delivery message. The sending message happens in two steps. The first one is that the user A, this user, will send the message to server A. So a user A will send the message through WebSockets connection for the server A. After that, the server A will checks the user connection cache, like in the cache here. Okay, because user A wants to send a message to user B. So user A will check the user connections cache of B. So server A check the user connection cache, usually a fast memory and a fast in-memory database like Redis, to find out the user's B, where the user B is connected, in which server user B is connected. Once server A knows which server the user B is connected to, we will go through the second phase, which is to deliver the message. So there are two possible outcomes before we go on this step. Let's first start if user B is online. If user B is online, okay, the cache will show that user B is connected to server B, okay? And a server A will forward the message to server B. Server B will instantly push the message to user B via their WebSocket connection, as you can see here, and it's done. But what if user B is offline? In this case, server A will send the message to the notification service. The service will trigger a push notification to alert user B about the new message. So let's recap what's happening here again. Number one, the user connection via WebSockets. Number two, the server with tracks connection in Redis. Number three, messages are routed across servers. Number four, offline users are noted via push notifications. So that's how real-time chat systems keep your conversation lighting fast. Want to learn more about this one? I guess yeah, we could create more videos talks about these things in details. I guess in the next video we will talk about how we will update the status of the message. How we will update the status of the message, like when the message is read, is sent, is delivered, things like that. So yeah, that's it for this video, and thank you for watching this video, and see you in future videos.